For question number 8, Almira is considering two different saving schemes. Both schemes involve an initial investment of $1,000 in an account. So we have here scheme A. At the end of each year, there is a $50 added to the account. And in scheme B, at the end of the year, 4% compound interest is added to the account. How much will be in Almira's account at the end of fifth year after investing in scheme A? So for scheme A, at the end of year, there shall be 1,000 plus 50 times n, which is 5. So that gives us 1, 2, 5. Doesn't right. 1250, 1250.00. I don't know what's the problem with this. Doesn't right. Withdrawal right. So, okay, wait. It's $1,250. So please wait for me to fix this stylus. Okay, 1250.00. For scheme B, it's compounded interest. So the principal plus the compounded interest of 1.04, because 4% is added, raised to 5. That gives us 1216.65. Okay, for letter B, what compound interest rate would achieve the same outcome for Almira's investing in scheme A for 5 complete years? So 5 complete years, it's 1250. So if we're going to invest at with a compound interest, the question is what shall be the interest rate? So it's 1,000. By the way, this is multiplication. 1 plus, we do not know the R. Since it's compounded annually, so R over N is 1 raised to 5. So using your calculator, this will generate a rate of interest which is 4.56%. So means she has to increase the rate of interest from 4 to 4.56, so that in n years they will have the same outcome. For letter C, Almira wants to invest for n complete years, so we're looking for the number of years. For what value of n would Almira be better off investing in scheme B? So for scheme A, it's 1,000 plus 50n, and for scheme B, you have 1,000 times 1.04 raised to n. So this is times, sorry. It will be better in scheme B. So there are two things that you can do here. You can do numerical solve, or you can use a spreadsheet where, for example, in column A, you can write x, and then 1, 2, 3, up to let's say 15. And then you have scheme A, you have to include a formula here, 1000 plus let's say 50x, because x is the number of years. And then you choose, uh, there will be two options like column or variable reference. So you use variable reference, and once you hit that, it will give you the values of this uh, amount. And then for scheme B, you can encode the formula 1000 multiplied by the 1.04 raised to x. And then again, use variable reference, and it will give you the different amounts for different years. So you can also see this one at 5. You'll have 1250 here at 5, and 1216.65. And you can see that it's better still to invest in A in 5 years. And then you go down and find out where, uh, at what particular year will you have, uh, or you can say where it is better to invest in scheme B than A. And you'll find out that it is N, when N is greater than or equal to 12. So it starts to pick a 12th year that it's better to invest in uh, scheme B. For letter D, Almira estimates that there is a 2.5 depreciation each year. How long would Almira need to save in scheme B to use her savings to purchase something currently valued at $1,400? So the depreciation rate is 2.5. So it begins at 4. So maybe the effective interest rate, uh, interest rate is 4% minus 2.5. That gives us 1.5%. So the money that we're trying to invest at have at the end is 1,400. So 1,000 times, using the effective interest rate 1.015. At what year will that be? Your calculator will give you 22.559. So meaning to say, in 23 years, I'll be able to purchase $1,400.